Subscribe now and press the bell icon. Never miss an update.
Hi friends, this is NP Chand. I hope you all are doing well. Let's see today's topic. I've taken today logic, or you can say symbolic logic. In logic, we will study statement, types of statements, truth value of statement, and then logical connectives, and finally we'll try to make the truth tables. Okay, so topic is logic. All everybody. Okay, what do you mean by the logic? This is not so new. You all know, you all are familiar about this word. Okay, so if we see the yoke meaning, then we find out the yoke logic, science of reasonings, or the science of reasonings. Okay, this is the dictionary definition of the logic, science of reasonings. For example, okay, one example. Let me create for logic. Okay, heaven wing is mortal. Okay, one statement is this one: human being is mortal. John is a human being. John is human being. Therefore, what we can say? There's a logic. Human being is mortal. John is a human being. So human being is mortal means, therefore we can say John is a mortal. Okay? So this is logic. Okay? This is the example of logic. Science of reasonings. Human being is mortal. John is human being. Okay? So therefore John is mortal. I guess you got it, this meaning of logic. Let's move now in important terms. Statement. In symbolic logic, or simply logic, we define these terms. Firstly, these are very, very important terms. Statement. What do you mean by this statement? Okay, so every sentence is not a statement, but every statement is a sentence. Okay, so statement, whatever sentences are called statements. See very carefully. So it's clear. Let me write down a declarative. Declarative sentence which is either true or false, but not both at the same time. This is called statement. Whatever sentence means a declarative sentence, or you can say the assertion. A declarative sentence which is either true, very important thing, or false, but not both at the same time. Okay. Examples. Number one, A greater than B. 2 plus 2 equals to 4. Okay. Number 3, 2 is to 2 equals to 4, or 2 into 3 equals to 6. Or you may say 2 plus 2 equals to 5. Okay. So see, either true or false. Okay. 2 plus 2 equals to 5 I have written, although this is not equal to 5, you know, right? But statement is, this is a statement but false statement. Okay, and we can write down. Okay, John is a good boy. Good boy. We can write them like this way. Mount Everest is in Nepal. Okay. So like this we can provide many examples for the statement. Okay. All right. David is a doctor. David is a doctor, or Rita is a nurse. These are the examples of your statement. Declarative sentence, okay, which is true or false, but not both, okay, at the same time, okay. These are the examples. So, what are the sentences which are not example of statement? Okay, example of statement. Here, I'm writing number one, not statement. Not statement. Okay, not statement means, okay. See, here I'm going to give you the examples of sentences which are not statement. What's up? Open the door. Open the door. These are not the declarative sentences. Okay? What is going on there? These are some examples of sentences which are not your statement, right? Because these are not the declarative, and here you can't find out the truth value. Okay, so you can tell, okay, whether they are true or false, right? So that's why, okay, these are not statement. Okay, in symbolic logic, okay, these are sentences we cannot take as a statement, right? For the statement we need, okay, declarative sentence which is either true or false, but not both at the same time. Okay, so these are the examples I have given. All right, so now let's talk about the types of statements. I hope you are clear about the statement. Okay, so now I'm going to expunge all these things because I don't have space, as you know. Okay, statement. Types of statements. We have two types, okay. Two types of statements. Two types of statements. Number one, simple statement. Simple statement. Number two, compound statement. Compound statement. Sorry, simple statement and compound statement. So let's see, okay, what are the simple statements? Okay, simple statement which declares only one thing. It's very simple. Which declares the statement which declares the only one thing, which tells about the only one thing. Okay, examples. 2 plus 2 equals to 4. 2 times 3 equals to 7. Although this is wrong, false statement, but tells only one thing. Okay. Shyam is a good boy. Shyam is a good boy. Only one thing. Dara is the capital of India. Delhi is the capital of India. So only one thing, okay, right? Okay, here 2 plus 2 equals to 4. declares only one thing, 2 times 3 equal to 7, although this is false. Declares only one thing, Sam is a good boy. Declares one thing, Dhaka is the capital of India. It also declares only one thing. So don't get confused here. Okay, sir has written there 2 times 3 equals to 7. Okay, intensely I have written. This is the wrong because false statement. Okay, statement can be true or false, right? So these are the simple statements. So I guess you are clear. Simple statement. Now I'm going to write on the compound statement. Then I'll provide you the examples also. Okay. Compound statement. Okay, compound statement. The simple definition I'll provide you. The combination of two or more simple statements is called compound statement. Simple combination. If we combine any two or more also, we can combine any two or more simple statements, right? And we get a one statement, that is called your compound statement, right? Later we will discuss about the types of the compound statements. The compound statements, so how we combine these two? We use logical connectives. Here we use some connectives. So by using some connectives we form one statement by joining some your simple statements, right? For example, now examples. The simply you can say the combination of two or more simple statements, all right, is called your compound statement. So example number 1, 2 plus 2 equals to 4 and 2 times 3 equals to 6. Because here combination of this is the one statement and here another statement, right? Two simple statements are connected. Okay. If ABC is a triangle, then sum of interior angles is equal to 180 degree. This is also okay. Here ABC is a triangle. Simple statement. Another one, sum of the interior angle is equal to 180 degree. So another, here we combined two simple statements. Okay, let's see the next example. Here, third example. You can. Rahim is a doctor, or David is a football player. Okay, this is also another one. Rahim is a doctor. This is one statement. David is a football player. Another statement. Here, the two simple statements are connected by this word. This is called the logical connectives. And here also, if then. I have connected, these two simple words by if then. This is the logical connectives, right? And here connected by, and, this also called, your logical connectives, right? In logical connectives, we will discuss, right? Now, these are the examples of your compound statement. So I hope you are clear about the compound statements, right? So let's talk about the simple statements, Simple, as I told you, there already, one thing I left, just I recall, there's the notation, So notation. The simple statement is generally represented by small letter P, Q, R, S, etc. Alright, we use the small letters, lowercase of alphabets P, Q, R, generally, just like P, P, Ram is a good boy, and Q you can say 2 plus 3 equals to 5. R says that 3 greater than 2. Here होगी simple statements होगी P Q R, right? So notation होगी, the simple statements are generally represented by the small letters P Q R. Okay, it is simple. Okay, statements done, types of statements done. Now let's talk about the truth value. See everybody, so what is your truth value of the statement? And truth value होगी, the statement होगी truth or falsity of the truth or falsity of the statement. Truth or falsity of the statement. Statement is called truth value. Okay? Truth or falsity. Truth or falsity of the statement is called truth value of the statement. Okay? Let's see now. Truth value. So if statement is true, if statement is true, then is truth value is denoted by capital T, or if false, then denoted by F. So simple. Truth value, see, truth or falsity of the statement is called truth value of the statement. Once again, truth or falsity of the statement is called the truth value of the statement. If the statement is true, then its truth value is denoted by capital T. If truth value of the statement is false, then its truth value is denoted by F. Okay? So, now here I am writing, okay. Number 1, 2 plus 2 equals to 4. Is correct? Absolutely correct. Then its truth value is T. Its truth value is T. Number 2, 2 times 3 equals to 7. No? 2 times 3 equals to 6. But here on the right hand side we have 7. It's wrong. It's false. Then its truth value is F. The truth value of this statement is denoted by F. If, let me write down one thing. Newton was dancer. Newton is Sir Isaac Newton. As we know, the Newton was a mathematician as well as physicist, well known, celebrated mathematician as well as a physicist, as we know. Okay, we never heard about the dancer, right? As a dancer. So this time, okay, I can say its truth value is F. Okay, all right. So its truth value is F. Okay, Newton. Got it? So I hope you are clear about the truth value of the statement, right? If truth value is okay true, then you can write down, okay, its truth value is capital T, or you can denote. And if truth value, if okay, statement is false, then its truth value is denoted by capital F. This is also done. Now logical connectives. Let's talk about the logical connectives. So some okay phrases, okay. Some phrases. We will discuss some limited phrases here. Or, and, if then, if and only if. Sorry. If and only if. Phrases. For example, okay, some phrases like or, and, if then, or, and, if then, if and only if, which are used to form a compound statement, which are used to join the simple statements in order to form a compound statements, right? is called logical connectives. Are called logical connectives. These phrases or, and, if, then, if, and only if, which are used to join the simple statements in order to form a compound statements are called logical connectives, right? Okay, these are used, okay, these are used, so these are used to combine simple statements in order to form compound statements are called logical connectives. These are used to combine simple statements in order to form a compound statement are called logical connectives. For example, so as I told you already, right? 2 plus 2 equals to 4, or have you used here or Ram is a good boy. Second one, Rita is a doctor, or Sita is a professor, right? And so let's use and so here I have used or to form a compound statement, and so like this way we can use if I go to market, then I'll bring mobile. Okay, so if I go to market, then I'll bring mobile. These are the some examples, of compound statements after joining these connectives, right? So already we have discussed, right? So logical connectives. Now, so what is the name of the compound statement when we use particular connectives, logical connectives? Let's say after joining logic on the basis of logical connectives, we have different names for the compound statement. Number one, conjunction. Number two, very interesting, disjunction. Number three, conjunction, disjunction, conditional or implication. Number four, biconditional. Conjunction, disjunction, conditional, implication, and biconditional. Okay. Now see, if I give the definition for one, then you can write down very easily for the others also, right? So what is the definition of conjunction? See, any two, see very carefully, definition of conjunction: any two simple statements connected by word and to form a compound statement is called conjunction. So see, okay, any two simple statements connected by word and to form a compound statement is called conjunction. So easy, conjunction. So and okay here. So this is the okay important word, okay. This word is playing here important role, okay. And so if this word is changed, okay, by another phrase, then it's gonna be entirely different one, right? Definitely. Any two simple statement connected by word and to form a compound statement is called conjunction. Conjunction. So symbolically we can write down, okay. P and Q are the simple statements. The conjunction is symbolized by P and Q. We read, okay, like this way, okay. If P and Q are two simple statements, okay, then conjunction is symbolized by P and Q. This way, okay. P and Q we read, okay. P and Q, okay. For example, we can write down, okay. 2 plus, very simple one example I am writing, okay. 2 plus 3 equals to 5 and 2 is greater than or equal to 1. This is the example of the conjunction. And okay, any two simple statements, okay, you connect by the word and, okay, that is going to form a conjunction, okay, that's going to be called, okay, conjunction, right? P implies P, sorry, okay, P and Q. Alright? So I guess you're clear. Now for disjunction, okay, everything. So any two statements connected by word, only this word is different, okay, or the same, okay, and here or, right? This word is or, then is called, okay, disjunction, right? If we connect two simple statements by the word or to form a compound statement is called disjunction. That's called the disjunction, okay. And we can symbolize, okay, this way, okay. If P and Q are two simple statement, P or Q. This way, okay, this disjunction is symbolized, okay, by this way. P or Q. We read out, okay, P or Q, right? Disjunction P or Q. Conjunction P and Q, right? Symbolized. And in conditional, what happens? Here only this word will be changed, okay. These two words, okay, will be, okay, replaced, okay. And is replaced by if dot dot then, okay. And then, okay, this called, okay, your conjunction becomes, okay, conditional, right? So if this word is replaced by if and then. Now what will be the definition of the conditional? Any two simple statements connected by the word if then, if dot dot then to form a compound statement is called conditional or implication, we can say, right? Implication. And symbolically we can symbolize, okay, conditional of two simple statements like this way. This is the, okay, this one. P implies Q. P is, okay, P and Q are the simple statements. Here P is called, okay, antecedent. P is called, okay, antecedent. Q is called, okay, consequent, okay, right? P is called your antecedent and Q is called your consequent, right? P is called, okay, antecedent and Q is called your consequent, right? So P implies Q. We read out, okay, like this way. P implies Q, okay, symbolized, okay, like this way. For example, I told you already, okay, if ABC is a triangle, then the sum of triangles is equal to 180 degree. If I go to market, then I'll bring chocolates, right? So these are the examples of the conditional, okay. The last one, okay, biconditional. And biconditional, and in biconditional the word will be, okay, connect, okay, if IFF, or we can read out, okay, if and only if and only if, IFF or if and only if. Any two simple statements connected by the word word if, or you can say if and only if to form a compound statement is called biconditional, right? Biconditional. And biconditional is symbolized by this way. If P is and Q are two simple statements, okay, biconditional, okay. P if Q. We read out okay like this. P if Q. P if Q. P I F F. P if Q or P if and only if Q. Q. This is the symbolized form of biconditional of two statements P and Q, right? P and Q are the simple statements. Okay. For example, okay, we can write down okay. Two triangles are congruent if IFF corresponding sides are equal. I've taken okay two statement okay. Two triangles are congruent if and only if corresponding sides are equal. What is the meaning of this one? Because okay here two-way implication we have. Right? Actually okay meaning of this one. Two triangles are if two triangles are congruent then is corresponding if their corresponding sides are equal and if corresponding sides are equal then two triangles are congruent, right? Okay, meaning of this one once again see. Two triangles are congruent if and only if corresponding sides are equal. Okay, in extended form we can read out like this way. If here to be an implication, right? If P then Q and if Q then P, right? If two triangles are congruent then corresponding sides are equal, and if two sides are if corresponding sides are equal then two triangles are congruent, right? So you may give okay any examples okay, whether it is true or false okay, it doesn't matter, right? But okay, in this way you can provide okay P and Q are the simple statements, right? So I guess you are clear about the conjunction, disjunction, conditional, biconditional. Okay. So once again, okay, let's summarize. Okay. See, conjunction or disjunction, conditional, biconditional. Okay. So look at here, everybody. Conjunction, logical phrase we use and connectives, and we symbolize like this P and Q, right? Disjunction or connected by word or symbolized okay P or Q. Conditional if dot dot then it can be symbolized by P implies Q, here IFF, or if and only if and only it can be symbolized this way P if Q. Two-way implication. This is called the one-way implication. Okay. So I hope you are clear. Okay, these are very very important. Okay, in logic. Conjunction once again. Okay, connected by and, disjunction or conditional if then, and biconditional if and only if. Right. This also done. Now truth table is left to be done. So in next video I'll tell you okay, because it takes time to because okay, not only one okay, we have to learn firstly how to make the truth table of conjunction. In next video I'll tell you with the solid idea okay, with very prominent idea okay, so that you will not forget okay, right? How to make the truth table of conjunction, disjunction, conditional and biconditional. Once you know the truth table, how to construct for these okay these compound statements, then you can construct the truth tables for any type of compound statements, right? Okay, so this is to be continued dot 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 tomorrow, and tomorrow in next video okay, definitely I'm going to tell you the truth table how to make okay, only based on the truth table. Next video will be, right? Okay, so thank you very much for watching. stay connected, and don't forget to share and comment. So like is very simple, okay, boys, okay, it's boys and girls is very simple, only just you have to press the button, okay. So thank you very much once again. Bye bye, have a good day, okay, have a great time.